So I'm Dave Schwaba, the product manager responsible for Geberit products in North America. Geberit is a European leader in the field of sanitary products with their products sold globally. Geberit North America is the market leader in the US and Canada for wall-mounted toilet systems. This is no surprise as Geberit invented the idea of a concealed in-wall system for wall-mounted toilets more than 50 years ago. There are millions of Geberit systems installed around the world, and we are preferred choice for plumbers everywhere for our quality and support. A note, Geberit North America is a member of the U.S. Green Building Council and a proud partner of EPA WaterSense. Note before starting, one is I'm going to hide my video so you can focus on slides and don't have to look at my mug. My presentation style is not to read the slides, but to summarize the slide and highlight the most important content in the 50 minutes we have. There's a lot of slides, there's a lot of contents. You will be provided a copy of this presentation by Geberit after the presentation, so no need to take notes regarding the slide content. We have also reserved 10 minutes at the end of the presentation for a Q&A session. Today's webinar focuses on how dual flush wall-mounted toilets contribute to modern sustainable bathroom design. We'll connect the technology behind these systems and the design and performance goals you work with every day. Cleaner lines for architects, reliable function and efficiency for engineers. There are four main objectives for today's webinar. One, describe wall-mounted toilet systems and determine how to incorporate them into bathroom design. Two, explain how wall-mounted concealed tank toilet systems can enhance durability, function, and style. Three, describe installation and mounting options of concealed tank systems. And four, identify and apply ADA design criteria and sound reduction techniques when planning washrooms for public buildings. Here's a summary of what we'll be covering. We'll start with an overview of toilet systems to set the foundation. I then will cover why choose wall-hung toilets, technology, installation, accessibility, acoustics, and end with some case studies. First, toilet systems. When designing bathrooms, architects and engineers must balance four priorities: design, quality, technology, and sustainability. Toilets play a surprisingly large role in meeting those goals. Modern systems have evolved far beyond basic plumbing fixtures. They're now part of the overall design language, helping create clean, efficient, and accessible spaces. Let's talk about the evolution of toilet systems. Yesterday is represented as a simple outhouse, but toilet technology has been more complex and evolving for thousands of years. Around 3000 BC, ancient Egyptians were already using early indoor toilets, and by 2500 BC, the city of Mohenjo-Daro in Pakistan had one of the world's first engineered sewage systems. The Romans expanded sanitation engineering around 800 to 700 BC with large communal toilets and extensive drainage networks. Fast forward to 1596, when Sir John Harington introduced one of the earliest flush toilets, and later in 1858, when London's Great Stink pushed engineers to create the modern sewer infrastructure we still build on today. Each milestone has moved us closer to the efficient, water-saving engineering systems like dual flush wall-mounted toilets that define modern design. Today, we have a variety of different toilet technology shown in the slide here, including the standard two-piece toilet, one-piece toilets, flushometer toilets, and the focus for today, wall-mounted toilets. Let's review each to understand the differences. The two-piece toilet is the traditional setup most people know. It's practical, cost-effective, but the seam between the tank and bowl can make cleaning harder. It also has a larger footprint, which limits design flexibility and impacts long-term maintenance. Dual flush systems are available, but not common. One-piece toilet streamlines the design by removing the seam between the tank and the bowl, offers a cleaner look, easier maintenance, but still occupies the same footprint as a traditional toilet and doesn't address the limitations created by the fixture resting on the floor. Flushometer toilets are common in commercial settings where durability and high volume performance matter. They deliver a strong flush and reset quickly, but the exposed valve and supply line don't always align with design goals. They also require higher water pressure, which makes them impractical for many residential applications. Wall-mounted toilet takes a completely different approach. The bowl mounts directly to the wall, while the tank is concealed behind it. This immediately frees up floor space and creates a clean, modern aesthetic. It also makes the area beneath the bowl easier to clean. Structurally, the in-wall carrier provides strong support, making these systems suitable for both residential and commercial installations. Now that we've looked at how different toilet systems compare, we can start talking about why wall-mounted toilets stand out. A few quotes on the benefits. Dan Brun, an architect, is quoted as saying, "I am a proponent of minimalist design where function is purposeful and aesthetics become inherent. Even in the design of my own house, as evidenced by choosing water-saving tank in-wall systems with actuators in my 4 bathrooms." And from Hanya Ray of Consumer Reports, "It's the stuff of a bathroom designer's dream, a sleek, space-saving toilet, absent that unsightly tank, which can be installed at precisely the right height for you. Plus, the nature of the design, a wall-mounted toilet doesn't contact the floor, makes it a breeze to keep the area around it clean." As our living and working spaces continue to change, flexibility in design becomes more important. Wall-mounted toilets allow layouts to adapt more easily, whether you're dealing with tight residential spaces or high-traffic commercial areas. The concealed carrier system opens up possibilities that floor-mounted fixtures simply can't match. This compact technology also prevents custom door designs like shown in the image shown on the right. Shockingly, we had several pictures like this that I could choose from to display. There are 5 key reasons why wall-mounted toilets make sense. 1, space savings, maximizing space. A concealed tank with the bowl floating above the floor creates the illusion of a more spacious bathroom, reducing the square footage required for a toilet by a minimum of 2 square feet per installation may result in a smaller, more profitable bathroom footprint, especially in densely populated areas like New York and other cities where square footage is at a premium. Hygiene. With an exposed floor and easy to clean surfaces, there are fewer places for dust and germs to accumulate. Less time is required for cleaning and disinfection, making wall-mounted toilets ideal for toilets or for hotels, workplaces, and modern busy areas. Number three, strength and durability. The carrier frame is designed for durability and can support up to 880 pounds without damaging the frame or wall surface. The high density plastic used for the tank is designed not to leak, as evidenced by a lifetime warranty on tanks and carriers. Aesthetic enhancement. With styles ranging from rounded to square, a wide variety of finishes, and options covering every budget, wall-mounted toilets allow designers to bring a sleek, modern feel to any kind of bathroom. They also allow flexibility in meeting building code clearances. Number five, reduced sanitary sound. Raising the toilet off the ground prevents noise from traveling directly into the floor. Putting the tank inside the wall further reduces noise transfer from flushing and filling. Plus, the unique design of the fill and flush valves results in a much quieter system than a standard toilet. Toilets consume approximately 25 to 30% of total indoor residential water use, higher than other household fixtures such as bathtubs, dishwashers, and showers. Toilets produced before the legislation of the National Energy Policy Act in 1994 used between 3.5 and 5 gallons per flush. Modern low-flow, dual-flush, high-efficiency toilets, HETs, meet or exceed current water usage standards, such as EPA WaterSense and LEED. EPA estimates that replacing a pre-1994 toilet can lower residential bills by up to $1,770 per year. Current wall-mounted dual-flush actuator plates include a large button for more water for solid waste and small button for less water for liquid waste. The dual option creates a 33% reduction in water use versus single flush toilets. The newest flush plates are available in dual flush touchless and also IR remote flush buttons that help prevent the spread of germs, perfect for private or semi-private or semi-public bathrooms where users are looking for the ultimate in comfort, convenience, and hygiene. Building codes are an important part of the system selection. California's Title 20 regulations set specific water use limits of 1.28 gallons per flush per plumbing fixtures, including toilets. The advantage of using dual flush wall mount systems is that users tend to use 3 small flushes to every large flush, making them a strong choice for code-driven projects focused on conservation. Sustainability efforts, including LEED certification, place increasing emphasis on water savings and long-term performance. Dual flush, wall-mounted toilets can contribute to these goals by reducing water consumption while maintaining reliable operation. This makes them a valuable part of high-performance building design. One example of this is the Museum of Contemporary Art in Cleveland. It's a LEED silver building that used wall-mount toilets as part of their suitability strategy. The dual flush system allowed the museum to achieve a 33% reduction water savings over traditional 1.6 gallon per flush toilets. Now let's dive into the technology behind the wall-mounted toilets. We have been discussing the benefits of wall-mounted toilets, but haven't gone over the components that make up the system. There are 3 main components of a wall-mounted toilet. A, tank and carrier, B, actuator or flush plate, and C, the ceramic toilet bowl. Let's go into detail on each element. Tank construction. The concealed tank and carrier frame consists of an in-wall concealed tank or cistern, which holds water, fill valves, and flush valves. This tank serves the similar function as the tank of a floor-mounted toilet. The carrier is a robust steel frame that holds both the tank and bowl and mounts to the wall. The one-piece tank used for wall-mounted toilets is made from lightweight, blow-molded, high-density polyethylene, HDPE, the same material used for automotive gas tanks. It is designed not to leak. The tank and carrier come in a few different models to fit a variety of wall configurations, including solid walls, both 2x4 and 2x6, wood stud walls, metal stud walls, full height walls, partial walls, also known as pony walls. It can even fit in corner installations. Service time is reduced to a minimum thanks to the lack of chains and flappers. There are also fewer parts that will corrode in the tank. Cleaning time is reduced due to easily accessible surfaces. There are few hidden or difficult to reach areas to clean than the floor-mounted model, which also means less bending and kneeling. A wall-mounted unit allows for easy maintenance as all components are accessible by hand through an access hole uncovered by removing the flush plate. Also called actuator plates, flush plates provide a stylish alternative to traditional flushing mechanisms. They come in a variety of styles, shapes, and finishes, which Jennifer will go over in the next session. Designers either seek to match or contrast other sink or bath fixtures. As previously mentioned, in dual flush touch plate systems, the small button uses less water to flush liquids, while the large button uses the full flush volume to handle solid matter. Flush plates also come in a touchless version. The main idea is reducing the transfer of germs on shared surfaces. When people use restrooms, especially in busy public spaces, the flush button is one of the most commonly touched fixtures. Touchless operation removes that contact point and helps limit the spread of bacteria and viruses. It's a simple upgrade that improves hygiene and gives users a cleaner, more modern experience. Since the early days of COVID, users have been increasingly sensitive to the potential spread of diseases through shared surfaces. This slide speaks to the technology of touchless flush plates using sensors to detect an object. The key takeaway is that the toilet can be set to either flush automatically when the user leaves, or can be activated by waving a hand near the sensor. Touchless flush plates may be powered through electrical wiring or via battery that can typically provide 200 flushes per day for 2 years. A manual override button may be used in case of power failure or dead batteries. Touch plates can also be programmable. This slide shows the use of a remote, but this is now more commonly done through the phone apps tied to the toilet system. Apps can be used for a variety of features: to adjust the sensitivity of the sensors, to pick whether to flush with a wave hand wave, or upon somebody leaving, and to set up a periodic automatic flush to prevent water stagnation in the piping and toilet. This is especially useful in vacation homes. Touchless flush plate advantages. Low power requirements can detect motion in darkness with reliability similar to lit areas. Does not require user contact, providing a hygienic, touch-free experience. Disadvantages: requires line of sight transmission, similar to a television remote, can be blocked by common objects. Limited range may be affected by environmental conditions such as dust, fog, pollution, and rain. Another important element to understand when selecting a unit is the different flush technology in wall-mounted units. So let's go to a standard toilet in the US. In siphonic toilets, a siphoning tube fills with water during flushing, pulling waste from the bowl and sending it down the drain. It requires a larger, elongated bowl to properly fill with water. Due to its narrow trapway, this style is prone to clogging, as I think we all know. Siphonic models are the dominant toilet style in America. They are not suited for dual flushing mechanisms or for wall-mounted toilets. In this diagram, you can kind of see how this type of toilet works. There's videos online that you can watch that are better, but water enters at A, air is sucked into the aspirator B from the siphon leg E before flowing through the rim C into the pan or bowl D, and then water from the bowl's first trap F is sucked through the siphon, flowing out via the second trap G into the drain. So it's a pull situation. In contrast, wall-hung toilets use a washdown flush. The gravity of water pushes the waste through a large trapway, so it exits the back of the toilet into the waistline. Because of this larger trapway than standard floor-mounted toilets, wall-mounted toilets clog less than floor-mounted toilets. This type of toilet will usually have a much smaller pool of water at the bottom of the bowl than a siphonic toilet. It operates better that way. This type of toilet is extremely common in Europe. So let's hit some review questions. What are the three main components of a wall-mounted toilet? You can say these to yourself, see if you can guess. The three are tank and carrier, actuator, which is also known as the flush plate, and the toilet. Let's move on to probably an area that's more interest to all of you, installation. Before a carrier is put in place, let's line up the basics so the install goes smoothly. There are 4 design elements that must be considered. 1, the finished wall. The wall material, number of layers, desired final thickness, and flush actuator type will help determine the overall finished wall thickness. Actuators are intended for finished wall thicknesses ranging from 3/4 of an inch all the way up to 3.5 inches. For the wall itself, glass and mirrored materials are not recommended. Number 2, framing. Each carrier model requires different framing based on the wall configuration. Carrier selection, seat height, and actuator style are interdependent and should be planned simultaneously. 3, plumbing. The water supply piping must be a minimum of 3/8 of an inch wide with working pressures between 2 and 125 psi, which is common for the US and Canada. The fourth area to consider is seat height, because this is one of those details that has a big impact on comfort and compliance. With wall-mounted systems, the carrier lets you fine-tune the final height, but you still need to account for everything that gets added during construction. Seat height, bowl model, seat model, finished floor thickness, they all contribute to the final seat height. The key is setting the mounting rods so that the final bowl height lands exactly where you intended. Whether that's standard height or ADA compliant, small miscalculations here can add up. So taking a few minutes early in the process to verify all the variables saves a lot of rework later on. On this slide, you can see the calculations that need to be made to determine the carrier rod height above the finished floor. You start with the target height for the seat above the finished floor, subtract the seat thickness, the distance from the rods to the bottom of the bowl from the target height. These values differ between brands and products, so they must be paid attention to. They can also vary greatly for bidet toilets or bidet seats. All must be considered to install the carrier correctly. In new construction, the installation process is very straightforward because you're working with open framing. The steps are: 1, attach in-wall tank system to the wall studs, either 2x4 or 2x6. Connect drainage, venting pipe, and water supply. Number 3, install finished wall over that, closing it in. 4, install the toilet bowl. 5, attach the flush plate. If a bidet toilet or bidet seat is being included, an additional line for water and a power source need to be included. When you're working in a remodel instead of new construction, the sequence shifts a bit, but the overall process is still straightforward. First, the old toilet and existing finishes come out so that you can open the wall and make space for the carrier. The big thing is moving the drainage line, and then you also move the venting pipe and water supply into the wall. The in-wall system is set in place, leveled, and secured, just like in new construction. Install the new wall panel, install the toilet bowl, and attach the flush plate. Even in a retrofit, the system integrates cleanly as long as the wall depth and structural backing are planned out ahead of time. And I do want to make note, I do see the questions popping in. I appreciate that. And they'll stage us up for the last 10 minutes, and I'll go through your questions then and provide answers. Now let's discuss frame options. There are a couple of different framing approaches you can use depending on the type of project. In residential work, a standard wood stud wall provides everything you need for anchoring the carrier securely. In commercial spaces, 16 gauge structural steel tubing may be utilized. One of the nice advantages of a well-mounted system is the flexibility you get with bowl height. The carrier frame allows you to set the rim at a range of positions, whether you're targeting a standard install, an ADA compliant height, or something tailored for your children's spaces. The photo on the right shows an example of a lower setting often used in school or childcare environments. This adjustability gives you more control over comfort and accessibility, and it lets the same carrier adapt to different project types without needing different models or special parts. When you're installing toilets back to back on a shared wall, there are a few specific requirements to keep in mind. The key in making sure, the key is making sure each unit has the right clearance and the proper waste connection so the two systems don't interfere with each other. Wall-mounted carriers can be positioned independently, but the plumbing layout needs to be planned so that drains, vents, and supply lines all line up cleanly. Thinking about that early helps avoid conflicts once the wall is closed up. Venting for a wall-mounted toilet works the same as it does for a standard toilet. There's nothing unique to account for, just follow standard plumbing code and the system will perform as expected. A big advantage of wall-mounted system is the flexibility you get with the waistline. Because the waistline is in the wall instead of the floor, you can run the waistline above the ground, something that you simply can't do with a standard floor-mounted toilet. Above the floor waistlines are typically used for commercial applications. They provide great cost savings for running above concrete floors or where breaking through the floor plate is undesirable, such as a basement bathroom, post-tension slabs, and historic buildings, which have severe constraints. Since the waistline isn't in the floor, this reduces distance between the floors, allowing for either taller ceilings or allowing you to fit a toilet in a location that just isn't possible with floor-mounted toilets. This also allows more flexibility in locating the toilet. You can mount a toilet anywhere along the wall. You aren't limited to a waistline in the floor. Designs can even change with minimal change to the plan. Below the floor waistlines are typically used for residential applications. They're ideal for service item access from below, such as basements and crawl spaces. Another advantage of having the waste pipes in the wall is for modular building design. We could have a whole entire separate class dedicated to the design of accessibility. What I want to cover now is just the high point level points to make you aware of what you need to pay attention to and some of the advantages of wall-mounted toilets in terms of designing accessible spaces. Wall-mounted systems work especially well in accessible bathroom designs because they remove some of the barriers that come with traditional floor-mounted toilets. With the bowl off the floor and the carrier adjustable, you can dial in the right height, improve transfer space, and keep the area around the toilet much easier to maneuver. Here is a list of people where accessible design helps beyond those with special needs, including people with stability and balance issue, extremely tall, short, or overweight people, people with temporary health problems like broken bones or recovering from surgery, parents attending to their children using strollers and baby changing activities, users of mobility equipment such as manual or powered wheelchairs, scooters, crutches, canes, and walkers, and also visually impaired individuals. There are two main benefits of using wall-mounted toilets for accessible design. One is the adjustable height to suit. Providing an ideal seat height in multi-use facilities is a design challenge as people have varying abilities and needs. Seat heights for wall-mounted toilets are adjustable only during the rough-in phase. Once installed, they are not adjustable. ADA compliant heights are between 17 and 19 inches. Number two, Wall-mounted toilets provide greater mobility. Placing the tank within the wall allows greater mobility in the bathroom compartment, saving as much as 9 inches of linear space. It also reduces the potential for injury. Removing the tank creates space for easier access to the grab bar. Here is a visual showing the advantages of a wall-mounted toilet versus a flushometer toilet in this kind of space. On the left shows a typical public toilet installation with a floor-mounted bowl and a flushometer directly behind the seat. While this flushometer is hands-free, it is also a giant obstacle in the middle of the working area and a potential barrier for the wheelchair user. This arrangement has the potential to cause injury if a person leans too far back or stumbles against the exposed equipment. The only solution is to improve this is with a toilet seat lid, if approved by the local authority having jurisdiction, which can create a barrier to the flush valve, but which comes with its own issues, one of which is cleanliness, as who wants to touch those in a public setting? The other is the additional hurdle of opening it, which can be difficult for some with physical issues. On the right is a public toilet installation with a concealed tank and carrier system. Eliminating the exposed flushometer valve improves greater mobility in the compartment and reduces the potential for injury. Now, this picture does show it with a toilet seat lid, but just like the toilet on the left, you don't need that for this application. Meeting ADA requirements while still maintaining good design flow can feel restrictive, but it doesn't have to be. What's important to remember is that the ADA standards are performance-based. They don't prohibit innovation. You can absolutely use creative layouts, alternative products, and new technology as long as they provide equal or better accessibility. That flexibility is where wall-mounted systems really shine. By lifting fixtures off the floor and freeing up square footage, they help you meet clearances and maneuvering space requirements without compromising design. So when you think accessibility, think opportunity. These systems make compliance and creativity work together. Now I'm going to go through the ADA requirements. I'll do this quickly, but here we're looking at the ADA clearances around the toilet. The key is preserving a usable box of space so the wheelchair users can approach, transfer, and turn. Standard 604.3.1 calls for a 60-inch minimum side-to-side clearance from that wall and 56 inches minimum out from the rear wall. In practice, that means we should protect this footprint from intrusions. No encroaching casework, slope bases, or pipes in the way. With wall-mounted system, it's easier to keep the floor clear, clean, and obtrusion-free. When it comes to ADA compliance, one of the most important details is seat height. Section 604.4 requires that the top of the toilet seat be between 17 and 19 inches, as I mentioned earlier. That may sound simple, but it's easy to overlook how floor finishes can affect that final measurement. A thicker tile or an uneven subfloor can push the seat height out of compliance if you're not careful. Wall-mounted toilets make that adjustment much easier because the carrier allows the bowl height to be set precisely. You can fine-tune the installation to hit that ADA range perfectly, even after accounting for tile or underlayment. It's a small detail, but one that makes a big difference in meeting accessibility goals with confidence. Flush controls also play a big part in ADA compliance. Section 604.6 states that they need to be easy to reach, and operate with tight grasping or twisting. The code calls for control to be located on the open side of the toilet. Unless you're working in an ambulatory stall, touchless or sensor activated plates make meeting the standards simple, while also improving hygiene and user convenience. It's one of those details that turns compliance into a better overall experience. There is an advisory for 604.6. It's as an important safety reminder. When flush valves or plumbing are placed directly behind the seat, they can cause discomfort or even injury. The best solution is to move that plumbing behind the wall, exactly what an in-wall carrier system does. Section 604.82 focuses on ambulatory accessible toilet compartments, those designed for users who can walk but may use crutches or other mobility aids. These compartments must have grab bars on both sides and enough clearance for side transfer. The toilet is centered within the stall, making it easier for users to approach from both sides. With wall-mounted systems, meeting these requirements becomes much simpler. The adjustable bowl height and open floor area make side transfers smoother and more comfortable, while keeping the design clean and efficient. This is a more involved diagrams, but it's really simple. Section 308.2.1 defines the forward reach for operable parts like flush controls or buttons. Highest part can't be more than 48 inches off the floor. Lowest must be at least 15. Flush plate well within these constraints. Another one, 308.3.2, where a clear floor or ground space allows a parallel approach to an element. The height of the obstruction shall be 34 inches max, depth 24 inches max. The high side reach should be 28 or 48 max, or 10 inches, a depth of 10 inches max. Where the reach depth exceeds 10 inches, the high side reach shall be 46 inches maximum for a reach depth of 24 inches maximum. A lot of wording or a lot of specs, but the key thing is wall-mounted flush plates make meeting these requirements easy, ensuring compliance even in tighter or more complex layouts. Some states go beyond ADA with their own clearance requirements. California has one where, in addition to the 60 by 56, there must be a 60 by 48 inch maneuvering space in front of the toilet. So wall mounting systems make it easier to meet these standards because they free up space. Review question. What are the 4 primary considerations when planning the installation of a wall-mounted toilet? Give you a moment to think about those. And the answers are 1, finished wall construction, 2, framing, 3, plumbing, and 4, the seat height. Let's go through acoustics. Acoustics are a big factor in user comfort, yet they're often overlooked in restroom design, whether at home, in the office, in a hotel. Unwanted sanitary noise from loud pipes, flushing or refilling can be a real nuisance. It's not just about distraction. Studies show that reoccurring noise can affect mood, concentration, and even sleep quality. With wall-mounted systems, Much of the noise is contained behind the wall, and insulated carriers help dampen the sound of flushing and refilling. The result is a quieter, more comfortable experience for both the users and everybody nearby. Some typical noise sources of sanitary noise include sound transmitting through the toilet to the floor and walls, large discharge pipes, and poorly planned bathrooms and rooms requiring sound insulation, such as bedrooms. We'll skip that because of time. So sanitary acoustic solutions, one is sound absorbing discharge pipes, which reduce noise at the source. Two, detaching the sanitary installation from the building. Place the drainage and flushing systems behind a pre-wall. Ensure that the pipes, the pipes and cistern have no direct contact with the building, as this will prevent noise from traveling through walls. Three, discharge pipes located on the same floor instead of in the room below, useful in hotels where it avoids disturbing guests in other rooms. So basically, number four is acoustically decoupling wall-mounted toilets, stopping noise from traveling through floors. Five, good overall acoustic planning. For example, in a residential setting, do not build a bathroom above a bedroom. I'll skip that. So I did want to just jump into some case studies. The Hotel Julian, originally built as Atlantic Bank building in Chicago. This structure had been severely water damaged and before it was transformed. So the big thing was the concealed tanks and wall-hung toilets, fewer edges, joints, corners, and an open floor space where the toilet is kept off the floor so dirt and bacteria can't hide. Give me a moment. My notes have disappeared. During the 75 million, oh, never mind, that's different. So another example is the Shangri-La Hotel and Condominium. They had 420 condo units and a hotel. Beyond their environmental benefits and long-term cost savings, the systems were chosen for their quiet flushing and short refill time. British Airway lounges are another one. I'm going to skip over those, but we have these and a lot more on our website. But for time's sake, I'm just going to flash some of these up. Urban townhouses. This was an IEC designed house that was restored in Philadelphia and kind of worked with the minimalistic design. Here's another one, Wisconsin farmhouse, residential powder room, back-to-back residential installation where they had the toilet back-to-back rooms, which actually saved a lot on plumbing. And children's bathroom, I had shown you an example of this earlier, but here's another one where it's just creating a special space for a family for their children to use. Review question, typical sources of sanitary noise, sound transmitting through the toilet to the floor and walls, large discharge pipes, poorly planned bathrooms, and rooms requiring sound insulation, such as bedrooms. Do have one bibliography, I'll skip over that. And the final slide, take the next step and reach out. So there's a handout tab that has the link to the global website. You can locate showrooms. You can contact our customer service and technical support, which is a huge advantage that plumbers love and architects. So there's also a lot of guides. There's some guides on ADA compliance, designing bathrooms that goes into more details. There's installation guides that give different solutions for buildings and, how to design. So there's a lot of resources. Don't forget YouTube, looking up Geberit, installation videos. But reach out if you have any questions and need help.